Okay, moving along to our next topic. So now we're going to switch gears. We talked a lot about implementation and the things that our various agencies have been working on in the fields. Now I'm going to talk a little bit about what our status is in the tributaries and in the lakes. So I just wanted to bring up a slide here at first about things to keep in mind. A lot of these are things we've mentioned before, but just to be a reminder, first of all, the amount of rainfall or discharge is a significant driver. We have the water monitoring summary available now for 2023. This is the discharge at the Maumee Waterville gauge by year. It's in cubic kilometers. You can see that 2023 was around about the same amount of flow as 2016, a little bit drier than it has been for most of the last, say, whatever that is, 12 years or so. So keep that in mind. And that is about 36% less than in 2008. So it's already going to be reducing our loadings just because of the reduced water flow. And we currently don't have a good method to separate this kind of a rainfall effect from management effort effects. Even if we were able to see some, response, it's just not, we don't have a good scientific mathematical model that is able to break it apart and say, yes, this percentage is because we did all of these things that we just talked about in implementation. So keep that in mind. Both load and concentration are important. So I'm going to be talking about both of those things kind of one after the other, but keep in mind that there's that interplay between the two. The concentration times the discharge is going to give you what your loading is going to be. And then bioavailable phosphorus is part of both the total phosphorus and the DRP. That's being used for the HAB forecast and the HAB severity index, but the targets that we have from Annex 4 and in the Maumee TMDL are not directly addressing bioavailable phosphorus as one number. So just keep all that in mind as we do a spin through a bunch of data tables and charts and maps. So these maps were in the domestic action plan. Last year in 2023, the maximum bloom severity was during August 10th through the 19th. And I just pulled the hypoxia model image for the same day. That's not the maximum hypoxia or the lowest oxygen. I just thought it would be better to compare it to day. So not the worst algae bloom we've ever seen out there, not nothing. But also, so in the left-hand side in the aerial photo showing the harmful algal blooms, the red color is the most intense of the algae bloom, pretty much hugging the shoreline at that point. On the right-hand side, the blue is the lowest temperature or the lowest oxygen levels. The top chart is showing the temperature. So the coolest part of the lake was in that first cell of the central basin there, and the warmest was in the very shallow western basin. The lower right is showing the dissolved oxygen levels. And you can kind of see this is something that has become more apparent in recent years, is this idea that the bathtub ring drops in oxygen first. And we think that happens because that volume of water is holding less oxygen. It's just a really thin, think of it like a dish. You're right around the edge of the dish, and that volume of water is smaller than it is in that big central area. So the sediments and the biological activity in that zone is using up the oxygen faster around the edge. And this particular image kind of shows that really well. By late August into September, the entire central basin area pretty much has some depletion of oxygen, and that whole area would be a darker blue. So when we look at that sort of in chart form. The lower right-hand one is, I think a lot of folks are following along with the HAB severity index that NOAA has developed. And I've kind of stretched the chart out so that the two on the right-hand side are one on top of the other. The top right is the number of frames that are listed as having excessive algae in 10-day periods throughout the summer season. So it's the same satellite imagery, but it's parsed a little bit differently. On the top, there's just a minimum number of cells. Everything above that, all of that would be counted as a frame that is not in attainment. So you're counting the number of times there's at least 20,000 cells in the unit of the lake. The severity index is a little bit more of an integration of how intense was the bloom and how long did it last together. So the two bars in the two charts are not always exactly the same. You can probably see that most obviously in 2022, where we had a really long season of a relatively low intensity bloom. It was still exceeding that 20,000 cell count for a really long time, but it wasn't very much above that. So when you look at it in terms of the HAB severity index, it's not an off the chart or an unusually high looking bar because it was a lower intensity bloom, but for a longer amount of time. But in terms of a use assessment, it was impaired enough to be counted against the impairment designation. So just providing those two as kind of two slightly different ways of looking at it. But the use assessment is specific to the designation of some of those assessment units as impaired for the purposes of developing the TMDL. And these data are reported in, I think it's section F of the integrated report, which has been finalized and sent to US EPA, but I think has not yet achieved final approval unless that was late breaking news. So that information is in the integrated report. And if you want to read in more detail about the methodology for figuring that out, all of that is provided there in that section 4. On the left-hand side of the chart, so, you know, in general, we're displaying here the harmful algal bloom status is extremely variable, but it's mostly still exceeding the objectives or the targets. Last year was relatively dry. The DRP load was actually below the 40% reduction level, but it, you know, was it because of all of our management actions or was it because of the rainfall being less? We don't have a way of separating those two effects that can really tell us the answer to that. You can see that we have had a number of years where the DRP load has been in the 20% reduction range, going back several years now. So we think that this reduction in DRP load is a real trend. And then also, if you look at the total phosphorus, you see that there is actually not that much of a trend. We do have some years where the total phosphorus load is a 20% reduction. This past year, there was a little bit higher concentration of total phosphorus, so it wasn't really much of a load reduction. But again, these are, for this, in this case, this is the spring loads. And you can kind of see in looking at the load, the models that developed these load targets were looking at what was happening in the lake and trying to back project what you'd have to meet at the tributaries. And you can kind of see in the figures on the right, there was a time when the phosphorus was high and the harmful algal blooms were high, and now the phosphorus levels are a little bit lower and the HAB severity is not quite as high. It's good to see that it seems to be correlating. Exactly why that's happening, we can't really distinguish between the rainfall pattern and the management actions at this time. Another thing I wanted to point out, we're trying some new methods to look at trends. This is an instance where we're trying to remove that effective flow. So we can say something else is happening here because we have flow normalized this. And it's called the weighted regression for time, discharge, and season. It's a method that was developed by USGS for Chesapeake Bay. The data has been loaded in for the Maumee, and I believe this is also, this I think is showing up through 2021. I think that there are efforts underway to continue to update it, to try to automate it so that we have this analysis done every year. But here we're looking at these loading. On the right, it's actually the annual load. On the left, I only had a chart for the spring load, but most of the load that's dissolved reactive phosphorus comes in the springtime. So it isn't going to be exactly the same, but the patterns look generally different. What we're seeing on the right is if you remove the effective flow, we think there is a distinct downward trend starting. And that's all we can kind of say about this. It's one way of looking at the trend, and we're still at Annex 4 level. There's work being done to parse exactly what that means, but it's consistent for both types of methods of looking at it. So we'll see how this goes, how it plays out as we continue. Another way of looking at it, kind of still thinking about how flow interacts with it. So I get this from Dr. Laura Johnson at the National Center for Water Quality Research. I am not sure if Laura is on today. If you are, I think if you raise your hand, you'll come to the top and someone can unmute you. I think, I don't know if I can do that from where I am, is the only problem. I don't know if I think any of our, I don't know if I can do that or not from where I'm at. Hang on a second.
I can unmute myself. Yes.
There you are.
Can you hear me?
Oh, you were. Okay. Well, somebody allowed you to, but all right. So I didn't want to just talk through your slide for you if you wanted to give it a go.
Sure, no problem. Yeah, so this is a figure and it's showing total particulate phosphorus, dissolved reactive phosphorus, and total bioavailable phosphorus, which is a combination of those both. And you can see the really small points and the line and then the dashed line are essentially the fit of the load, that March through July load to stream flow for 2002 to 2018. And so you can see the fits are pretty good. The dashed lines are, essentially the 95th confidence intervals. They're not quite, they're prediction intervals, but basically where you would expect loads to be if they were not different from what we saw in the past. And then that little gray line, Sandra has really well noted on here, is where the targets are. So remember, those are static load targets. And basically from there, I show each year since 2018. And I made this figure originally because 2019 for DRP and total bioavailable phosphorus was lower than expected. So you can see those two circles on those figures being like outside of those confidence intervals. But what this is really highlighting is 2023, where you can see that while our DRP and total bioavailable phosphorus were lower than the targets, they were lower than targets because flow was so low, and they were actually kind of right where we would expect them to be. Interestingly, total particulate phosphorus was a little bit higher than expected, and that might just be because what I have gathered was that there might have been a little bit of additional recreational fall tillage the fall before due to it being fairly dry in 2022. So yeah, I think that's everything.
Yeah, thanks, Laura.
Yeah.
All right. And just talk for a minute here about the flow weighted mean concentrations. This is another way of sort of approaching limiting the kind of the effective flow on the data set. You're basically boy, that's a complicated target. Do I want to try to get into that or not? It's the concentration values, and it's not perfectly divorced from flow. It's not as divorced from flow as the WRTDS method, but it's sort of an easy way for us to kind of try to get at that. So in terms of flow weighted mean concentrations, the flow is very sensitive to the amount, I'm sorry, the load is very sensitive to the amount of flow. So you can say, you know, so last year DRP was 40% reduced. But when you look at it in terms of the flow weighted mean concentration, it's not that much lower. So we know that there's still work that would need to be done to bring that flow weighted mean concentration down, because that would have to be low and stay low in order for the loads to be low at higher amounts of discharge. So what we see here, just another way of looking at it, again, we do seem to see a little bit of that decrease in the flow weighted mean concentration for the DRP. On the right-hand side, the total phosphorus flow weighted mean concentrations bouncing up and down, coming down a little bit, going up a little bit. Last year was a little bit higher. So just another way of looking at it. And again, keeping in mind that we did not really have a way of determining what proportion of our actions or which actions are possibly contributing to any decreases at this scale. These data and the data that we have for a selected subset of stations are available in the water monitoring summary, which is for 2023, which is on the commission website. If you go to our planning tab on our website, you should be able to find the card that has the water monitoring summary on it. And so you can download that fact sheet and take a look at it. The question was a little bit earlier, you had asked about the extended water monitoring summary. Right now, we are not planning on redoing that effort. The base data are available directly from both USGS and from Heidelberg, and some of those are displayed in ways very similar to what we display them. And so the current thinking is that we would just refer folks to those websites too. Then you can click on whichever stations you want to see and can look directly at all of those data rather than us trying to regurgitate them in some kind of a spreadsheet format. So we did not have plans to do that. And that's all I have for the monitoring data piece. Comments or questions on that? And I think there's been stuff going on in the chat. Let me review. Okay. So Josh says the integrated monitoring report was approved on April 19th. So that was late breaking news. All right. Okay, yeah, Tanya mentions that WRTDS would also help address the climate question, which is another factor that we know is interacting with all of this, you know, trying to tease apart, you know, it can be a bit of the Red Queen's race or doing all of this implementation activity, and it may not seem to be showing up in the data, but perhaps we have climate factors that are also pushing us in the other direction. So we may be having more of an impact than it's easy to measure. We'll see. All right. Questions. All right, so let's see. USGS, Santina mentions USGS has a new trend mapping tool that has a few sites in the Maumee. It'll be interesting to see how that compares. Yes, I have seen that. All right. Any other questions or comments? My plan is just at this point to open it up for discussion or raise your hand. We can, I'm going to see if I can unmute everybody all together or allow you to unmute yourself. But in the meantime, That'll work. All right, I think you guys should be able to unmute yourselves, but please raise your hand so that we can call on you. If you have any other questions or comments about any aspect, if you have lingering questions or if we missed anything as the chat was going by. Any other questions in the room? Comments? No? All right. Tanya, you want to go ahead?
Sure, thank you. I just want to point out that we're getting to a point where we have about 10 years of monitoring data on a lot of smaller streams as well. And so understanding that link between, and I know that Heidelberg does as well. And so there's a lot of both kind of independent and then collaborative work looking to understand and separate that climate effect and what we can learn spatially, because right now a lot of our information is focused on one location.
All right.
Santina, did you have anything else to add on that point?
No? Okay. All right. Well, I would just like to let everyone know that for follow-up, we are always available. You can either email the DAP at ohio.gov or the DAP at lakeerie.ohio.gov email for questions, or you can email me directly, sandra.kosek-sills@lakeerie.ohio.gov if you have additional questions about the domestic action plan. I see Laura is just saying early season HAB projections start next Thursday. So that'll be good. I know we're already well into April, so we've got information about that. And I do have just a quick bit to close. So we are still looking ahead to seeing the U.S. federal domestic action plan come out. That is still underway. I believe that Michigan also still has their domestic action plan underway. So there will be more DAP stuff in the news. Of course, for Ohio, we're going to continue with the H2 Ohio program work. We'll continue to implement the MOMI TMDL. Keep an ear out as the biennial reporting gets developed. I'm sure that will be coming out towards the end of the year. I think the nutrient mass balance is also something that will be coming out. Josh, if you do you want to say a word about that briefly?
Sorry, what was the last question there?
The nutrient mass balance, that's coming out yet this year, right?
Yeah, it'll come out this year. I'm a little bit less involved with it than I was in the past, but definitely been talking with our folks here and there who are working on it, and they're making progress, and I think we'll see it later this year for sure.
Okay. All right. And as far as reposting the slides, yes, I believe we will do that. I've been recording the meeting, so I'm hoping to be able to post the recording on our YouTube channel. And when all that material is available, I'm going to send it back out to the broader list of stakeholders. So folks who were here will get it, but also all the folks that were not able to attend. So thank you, everyone, for coming. I appreciate your time and attention, and hopefully we will just get back to work and get some things done. Thank you.